Hello and greetings everyone. I, Nimish Sharma, along with my colleague Georgie Jacob, would be presenting our paper titled Target Value Design, Development and Testing of a Virtual Simulation, co-authored along with Dr. Zofia K. Ripkowski and Dr. Ganesh Devkar. These are the following subsections of the paper, which includes the general introduction about the paper, the TBD simulation, simulation development, simulation testing, post-simulation discussion, and finally the conclusion. Starting with the introduction, serious games and simulations have been explored since early 1980s by many prominent lean researchers and scholars such as Greg Howell and Glenn Billard. They have effectively instilled the concepts and principles of lean construction among the participants. But due to the current COVID-19 pandemic, these lean simulations and games that were previously played in person have been largely impacted. Hence, there was a need for an online simulation to teach TVD despite the current social distancing norms present globally. So target value design evolved from target costing in Toyota's production system in Japan. It involves continuous collaborative cross-disciplinary appraisal of design proposals. It improves the overall value of the design proposal in terms of key value propositions such as cost, design, risk, constructability, quality, and time. Early collaboration of stakeholders, setting a target cost, and rigorous estimating are the key requirements of TVD. The target value design simulation has been inspired by the Marshmallow Design Challenge game prepared by the Peter Skillman. It's been widely used by educators to impart principles of TVD such as market cost, allowable cost, target cost, collaboration, etc. This paper discusses the development and testing of a virtual TVD simulation at CEPT University, which is an improvised version of TVD Marshmallow Tower game prepared by Munan Kami and Dr. Zofia K. Ripkowski. This simulation involves the design, construction, and costing of a virtual tower. The specification of this tower is 26 centimeter height and 12 centimeter as its base. It includes two rounds consisting of round one, which involves the traditional mode of development, and round two consisting of the collaborative mode of development. The total time required in both the rounds is approximately 75 minutes. Google Slides have been used as the online platform to develop and test this simulation. The total participants required in each team are 3 to 4, which includes one designer, one contractor, and 1 to 2 owner. The general materials required to play this simulations are the various templates prepared, such as TVD game template, instruction slides, and the cost sheet template. The instruction slide provides related information to team composition, role playing, and general instructions for playing round one and round two. It also consists of a resource sheet with various shapes used for constructing the tower. It's followed by the TVD game playing template, which includes the tower construction template, the template for RFIs, template for uploading the design proposal, and the template for providing client's brief. Finally, there's a cost sheet template, which consists of a table itemizing the predefined cost rates of each shape, the number of shapes used in the construction of the tower, and the total cost of the tower.
Hi everyone, I'm Georgie Jacob and I'll be handling the remaining section. Moving to the next section, which is simulation testing. The simulation was tested with a group of postgraduate students doing construction engineering and management at CEPT University. We divided the students to 6 teams with 3 to 4 students in a team. In the image shown in the right hand side, the upper side shows the first round, which was the traditional mode where communication was allowed only through RFIs, and the lower part shows the images for collaborative mode. Round 1 was approximately 45 minutes, in which the designer sketched his design based on the client's brief. The contractor constructed the tower based on the designer's proposal. Then the cost sheet, which was discussed in the previous slide, was not shared till the completion of round 1 to avoid any influence of the cost during the preparation of owner's brief and design proposal. After the cost calculation, there was a brief discussion to establish the market cost, allowable cost, and target cost. After setting the target cost, round 2 was played and the cost was calculated. This time, since there was no restrictions in communication, the coordination of all teams were enhanced than the previous round. After both the rounds, the Excel sheet with the populated data of each group is projected in the screen in the Meet virtual room. You can see the summary of the data here in this table. C1 is the cost of each team's tower came up in the first round. Market cost is the average of these costs. 20% was reduced from the market cost to get the allowable cost. Each team then declared the target cost for round 2. The cost in the final round, which you can see here, turned out to be lesser than the average cost for most of the teams. Moving to the post-simulation discussion. For evaluating the simulation and taking feedback from students, we chose the questionnaire developed by Munankami and Dr. Ripkovsky for the tower game which they have developed. The questionnaire was floated to the students in the form of a Google form with 23 questions in total, out of which we are showing the 7 major parameters here. The students were asked to immediately provide responses to the questionnaire, since learnings and their aha moments were likely still fresh in their minds at the end of the simulation. The points C, F, and I, as you can see in the slide, were rated higher, which were collaborative environment and decision making, open communication, and simultaneous budgeting and estimating through collaboration. Most respondents gave a higher rating for the parameters of mutual trust and reward. Involvement of key stakeholders assisted in a team's development of innovative towers not only met owners' needs but also lowered the cost of construction. Based on the discussion, it was evident that the simulation was effective in providing a first-hand experience of this TVD concepts. The analysis of questionnaire responses indicated that the concept of target costing was understood by the participants. So, from the whole simulation, we have concluded that TVD promises monetary gain as well as it enhances the collaboration, transparency, and teamwork. At the development stage, it was a little doubtful for us whether this virtual simulation would be as effective as the tower game by Dr. Ripkovsky. But the responses from the students indicated that the key concepts for understanding the TVD were being imparted. Also, this served as an effective replacement for a tower game during the COVID-19 pandemic. Thank you.